Hi everyone, I hope you are doing well. In my previous videos, I've opened up about my mother and my fascination with pastry making. Today, I'd like to add a touch of my love for cinema. You may know Modern Times of Charlie Chaplin, that movie of 1936, where he plays a factory worker on an industrial assembly line. Each station does one thing, precisely at the right speed, in the right order. No one does their neighbor's job, and if one station breaks down, the whole line stops. Your digestive tract works exactly like that, and that is exactly what we are going to explore today. Because after explaining what a protein is and discussing about our needs to proteins, it is time to tackle a crucial step: how your body digests these proteins to release the amino acids that will build your own proteins. When you eat, whether an egg, lentils, a slice of bread, or a piece of cheese, everything you ingest follows the same path, the digestive tract. 4 major stations follow one another. The mouth, the first mechanical and chemical transformation, teeth grind, saliva moistens, and the first enzymes get to work on carbohydrates. The stomach, an extremely acidic environment, the pH between 1.5 to 2, that denatures food structure and triggers the first proteases. The small intestine, the heart of the digestion and absorption. This is where the majority of nutrients, carbohydrates, lipids, proteins, vitamins or minerals are broken down into absorbable molecules and enter the bloodstream. The final step is the colon, the final station. Water is recovered. Non-digestible residues ferment under the action of the microbiota, and what cannot be used is eliminated. I am putting here a diagram showing the digestive tract. All your food follows this path. What changes is how each type of nutrient is processed at each stage. Today, we focus on one passenger, the protein, and its journey is particularly fascinating. Let's start with the first step, the mouth and stomach, where we have mechanical and chemical deconstruction. It all starts before you even swallow. Chewing breaks the physical structure of food and exposes proteins to enzymes. This is step 0, essential but often overlooked. Then comes the stomach. 2 players enter the scene, the acid and the enzyme. For the acid, we have hydrochloric acid that brings the pH down to 1.5 to 2. This extreme pH denatures the proteins. It breaks their 3D structure, unfolds them, and makes them accessible. Remember, in my first video, we looked at the structure of proteins. I insert here the structure diagram. So when protein is denatured by acid, we end up with a more or less unfolded chain, making the bonds between the amino acids accessible. The second actor in the stomach is the pepsin, which is a proteolytic enzyme secreted in the stomach in an inactive form that we call pepsinogen. It is the acidic pH conditions that activate it into pepsin, which then acts on the peptide chain. Pepsin hydrolyzes peptides bonds at neutral amino acids with large aliphatic or aromatic chains. This gastric proteolysis is incomplete and mainly generates large non-absorbable peptides. It prepares the ground. It doesn't finish the job. Then it comes to the small intestine, the heart of the process. This is where the real proteolysis happens. The acidic gastric content arrives to the duodenum, which is the first part of the small intestine. The pancreas secretes bicarbonate that raises the pH to 6 to 7, and with it a battery of enzymes in the form of inactive proenzymes. Several enzymes act on the peptide residues. We have trypsin, chymotrypsin, elastase, and carboxypeptidases. These enzymes are activated in a cascade. Trypsin is activated first and triggers the activation of the other enzymes. These proteases works as a team with complementary specificities. Trypsin cleaves after basic amino acids, arginine and lysine. Chymotrypsin cleaves after aromatic amino acids, phenylalanine, tyrosine and tryptophan. The pancreatic elastase cleaves after aliphatic and polar amino acids, as valine, alanine and serine. The final product of this coordinated digestion is almost 30% of free amino acids and 70% of peptide chain of 2 to 6 amino acids. There is a diversity of results in the different studies on those chain lengths. Then the brush border enzymes of enterocytes, which are the membrane of the small intestine, we have aminopeptidase and dipeptidase. They will finish the work. So we have then the D and tripeptides that are absorbed directly via transporters as the PEP-T1. The last station is the colon and the microbiota. So the peptides that escape digestion in the small intestine enter the colon, where they are partially converted by the microbiota into various compounds that can be more or less absorbed. Bacteria ferment these protein residues and produce short-chain fatty acids, ammonia, and modified amino acids. The microbiota is, in a sense, the fourth player in protein digestion. And why all of that is important to understand? Because it is contributing to understand the nutritional quality of a protein. The way a protein is digested and then the amino acids released and made available define the nutritional quality of that protein. This is the principle behind the PDCAAS and the DIAAS scores. So two indices put in place by researchers that measure both the content of essential amino acids and their real digestibility. We'll come back to this in a future video. So to finish my video, there are 3 takeaways. The first one, protein digestion is sequential. It involves 4 successive stations: mouth, stomach, small intestine, and the colon, each with its own enzymes and conditions. None can replace another. The second point, enzymes work as a team and in a cascade, from pepsin to trypsin, chymotrypsin, and elastase. Each enzyme has a precise specificity. Together, they release the amino acids that build your own proteins. The third point, the quality of a protein is measured by what is truly absorbed. The way a protein is digested and the amino acids made available define its real nutritional value. This is what the PDCAAS and the DIAAS score measures. In an upcoming episode, we will explore the digestion models that form the foundation of Didier Dupont's research. Don't miss it. On the scale of some, the difficulty of those videos, I put a score of 4 out of 10. So let me know in the comments if you agree with that. Thank you and see you soon.